The objective of this lesson is to solve linear systems of equations using graphing and substitution, and to compare the two of them. So first of all, we want to look at what a linear system might look like in the different ways that they show up on the graph. So if you look at two lines graphing, if you graph two lines, they could just intersect in a single point, so that would be one solution. The ordered pairs of that point would be the solution. Now it could be that you would graph the line, and then after you graph the line, when you graph the second line shows up instead as a line right over the top of it, meaning that they're the same exact line. If that's the case, then there are infinite solutions. In fact, the solution to this one isn't just a point, it's every point on the line. So the equation of the line, the solution, is the equation of the line. Gives you the entire line for the answer. The last case is when you have parallel lines. If you have two lines, when you draw them, they have the same slope. Those two lines will never intersect, so there's no solution. We sometimes will call that, a term we'll use is inconsistent. So no solution would be inconsistent. So these are the three visuals for what could happen with a linear system. Two lines could be any one of those three. When we solve by substitution and we solve the equation, when we get one solution, it will become pretty clear. You get an x and a y and you're done. But what happens if you solve and you have no variable left? Okay, no variable, so you have two numbers with an equal sign. So you have a number equal to another number. If it's a true statement, so let's say you get 5 equals 5, that's a true statement, then you have infinite solutions. The whole equation of the line is it. So this would mean the same line. Whereas if it's a false statement, let's say there's no variable and you get, for instance, 5 equals -7. That's false. If you get a false statement, then they're parallel lines. So there would be no solution. So let's go ahead and do some examples for these. First of all, we're going to graph them, see where they intersect, and then we're going to do it by work through the problem with using substitution. So these two, you could go ahead and set it into slope-intercept form by getting the y by itself and then graphing it. Another way to do these problems is to do it by intercepts. This is a little different than how we've graphed up to this point. Graphing by intercepts that means you're going to be putting in x equals 0 and find the y, and put in y equals 0 and find the x. That will give the x and y intercepts for the graph, and then you can connect them. Okay, it's usually easier when the graphs are in this form where they're not, they can be put into slope-intercept form, but they're not already in that form. So if we put in 0 for x here, we're going to get opposite of y equals 5, so y equals -5. So 0, -5 is my intercept there. So x equals 0, y, when you solve that, will get -5. Now let's go ahead and do y equals 0. If you put in y equals 0, you get x equal to 5 for this one. Okay, so we're going to get for this one y equal to 0 and x equal to 5. And so here's our line when we draw it. Okay, now let's go ahead and graph this one the same way. I'm going to put in x equals 0. And when I do that, I get x equals 0. You put in, you get 2y equals -4. So y equals a -2. So y equals -2 right there. Let's do this. These points go together. So I put in y equals 0. Y equals 0, x would equal -4. So right here. So when I draw this one, I get a graph like that. And there is my intersection point. So what I get for that intersection point is I get an intersection of 2, -3. All right, so that's how you do it by graphing. Let's do it by substitution. Now the first step for substitution, if you recall, is we look at our equation, we get one of the variables by itself. To me, out of these two, probably the easiest would be to add y to both sides. So what you would get is x equals 5 plus y. And then we take the second equation, x plus 2y equals -4. And we're going to go ahead and substitute this one into it. So this 5 plus y is going to go in for x right there. So that's my substitution. So 5 plus y plus 2y equals -4. If I go ahead now and simplify, because the parentheses don't get in the way of the addition, so we got 5 plus 3y equals -4. Subtract 5 from both sides and you get 3y equal to -9. Divide by 3 and you get y equal to -3. Now, in substitution, you got to repeat that process to get the x. So I'm going to pick one of the two equations. I'm going to pick the first one. I'm going to substitute this in for the x. Then x minus y equals 5. So when you put that in, you get x minus -3 equals 5. Minus the negative ends up being plus. Subtract 3 from both sides and you get x equal to 2. So my ordered pair is 2, -3 for a solution. And you can test it back in these two, but notice my answers for substitution and graphing match. Let's go ahead and do the next one. So for this one, let's do the graphing again on this. On this one, we're going to go ahead and do our intercept method. So if I put into the first one, I'll do it right next to it here, x equals 0, I get y equal to 7. If I put in y equals 0, I get x equal to 7. So I plot those points. 0, 7 is right here, and 7, 0 is right here. Just draw the line. Now let's graph the second one. Now if I do this one, if I put in x equal to 0, I'm going to get 2y equal to 2, so y equal to 1 here. So I'm going to get, for this one, x is 0, y is 1 right there. And then if I do y equals 0 for the intercept, I put that in, I get 2x equal to 2, x equals 1. So I end up with 1, 0. If I graph that, I get a parallel line to that one. If two lines are parallel, like we learned about, there is no solution. They don't cross. No intersection. Let's go ahead and do it by substitution just to see what happens. So on these, which equation is it easier to get one of the variables by itself? Well, it looks like you could get either x or y in the first one by itself. This time I'll get y by itself, so I'm going to subtract x. So I get y equals 7 minus x. I'm going to take the second equation, 2x plus 2y equal to 2. I'm going to put this in for y right there. So we get 2x plus 2 times 7 minus x equals 2. Distribute through, 2x plus 14 minus 2x equals 2. 2x minus 2x gives me no x's, so I get 14 equal to 2. So notice we ended up with, as we talked about, there are no variables left when I solve this equation. Well, no variables in a false statement, okay, that is not a true statement. That means that there's going to be no solution to it. They are parallel lines. So that's what it will look like when you get that answer. All right, let's try the last one down here. Okay, we're going to first of all do it by graphing. So looking at this graph, this one will give me some fractions. So I'm going to go ahead and do this one in slope-intercept form. So I'm going to go 3x plus 2y equals 2. I'm going to subtract 3x from both sides. And then I'm going to have the plus 2. Divide by 2 on both sides. And so if I divide by 2, I get negative 3 halves x plus 1. And so when I graph that, I get a 1 here. Start at 1 on the y-axis. Then down 3, 1, 2, 3 over 2. Down 1, 2, 3 over 2. Draw the line. Okay, let's do the second one. Get it into slope-intercept form also. So I'm already got the y over on the one side, so I'm going to divide everything by 4. So y equals 1 minus 6/4 x. Now I'm going to simplify that, and I'm going to have y equals 1 minus 3 halves x. Well, if you look, this matches that. If I just rearrange and put the x term first, that's negative 3 halves x here. Okay. So negative 3 halves x, then plus 1, because that's a positive 1. They're the exact same equation. If I were to graph it, it would be right on top of it. So my solution is the entire line, which is, in this case, I'm going to go ahead and list it in slope-intercept form. The solution is y equals negative 3 halves x plus 1. It's an infinite number of points, because there's an infinite number of points on that graph, on that line. Let's see what that looks like when we substitute. So I've already gotten y by itself here, so I'm going to take y equals negative 3 halves x, and I'm going to, 3 halves x plus 1. I'm going to substitute it into the second equation. I'm going to list it that way. So 4y equals 4 minus 6x. Let's substitute this in for y there. So what I get is 4 times negative 3 halves x plus 1 equals 4 minus 6x. So multiply 4 through. 4 times negative 3 halves. The 4 reduces with the 2 and leaves me with negative 6x. 4 times 1 is equal to 4. Equals 6 minus 6x. Add 6x to both sides and you get just 4 equal to 4. Now remember, once you get down to the point where you have no more variables, but a true statement, so this is true, what we get is the entire line is the answer. So we get an infinite number of solutions. That gives me this as my solution for it. So remember, when you're solving a system of equations, graphically you've got three options. Either they intersect in a point, they're the same line, or they're parallel, and there's no solution to that one. And how that looks in terms of substitution is, if you solve it and you get an x and a y, you've got 1 point. If you eliminate all of your variables with substitution and get a false statement, there's no solution. You get a true statement, it's infinite number of points, and the answer is actually the entire line for us. So solving systems of equations, you can do it either way, visually by the graph, or substitution, you can do the algebraic method.